right, so going along the lines of simplifying radicals, we're going to talk about some operations the next couple of days dealing with the same radicals. And again, we're going to still focus on square roots, although the same things can be kind of taken and applied to other types of roots as well. So adding, subtracting radicals is what we're focusing on today. What you really want to think of, let's kind of avoid, maybe almost cross out the radicals part, and think about what have we done when we've added and subtracted in the past this year. What have we used when we've done it in algebra this year so far? The answer is, hopefully you think this to yourself, the answer is when we add and subtract, we're always looking for like terms. So whether we're talking about x squareds or x's and y's, we're always talking about like terms. So in square root expressions, or any root, really any root expressions, you're looking for like terms, which would be like radicals. So what makes it a like radical is the exact same radicand. So if you remember with your square root, if you look in your IMB, the number out front here, the little number here that tells you which root we're taking, that's the index. The number on the inside of the root is the radicand. So when we talk about like radicals, square root of 2 and 5 square root of 2. They have the same radicand inside that square root, so that makes them like radicals. Any other form, so square root of 2 and square root of 6, any deviation from those radicals being identical would be cases where we can't add them together. So adding and subtracting is all about the like terms. In this case, we're talking about radicals. It's all about the like radicals, the like radicand. So it doesn't matter what numbers I put outside of these, square root of 2 and 2 root 6. It's those radicands that have to match. So I'm going to do a couple as an example, and then you're going to try some on your own. Oh, sorry, before we do the I do and the you do, how do we combine like terms? How do we combine like radicals? It's the same way we've done all year long. So think about 2x. You're looking at the x and the x matching to tell you that they're like terms. So how do we add 2x and 7x? We add together. It's all about the coefficients. So we say 2x and 7x is 9x. Notice we didn't do anything to the x. The like term came along. It was like we have 2x's and 7x's. So how many x's do we have all together? We have 9. So when you do this with radicals, same idea. Here's your like portion. The radical tells you that they can be added together. So it's like you want to think of it as 2 square roots of 5 plus another 7 square roots of 5. It's like how many of the square root of 5 do you have? So you have 9 square roots of 5. So just like with any like terms, you add the coefficients or subtract them depending on the sign. You add the coefficients and then you just keep the like term portion. So the like radical in this case we keep. So now to the I do's, to add and subtract some like terms here. So again, if we're looking at a whole list of things, there's square root of 3. Only thing that can be combined with that 9 root 3 is another square root of 3. So this is another square root of 3, but then this 3 is not a like term. So this 3 doesn't get to combine with anything, and we combine 9 root 3, take away 4 root 3. So 9 minus 4, I pay attention to the coefficients, and I say, okay, if I had 9 root 3's and I take away 4 root 3's, I'd have 5 root 3's left, and then the 3 didn't get to combine with anything, so it just comes along. Notice it's not under the root. The root ends with the 3 there, so you got to watch out how far you're dragging that, taking that root along with you. You don't want to include more under that square root than you mean to. For letter B, we have square root of m minus 7 square root of m. So the square roots match. So these are like terms. So it's what are we subtracting away? we're trying to do the coefficients, we're saying minus 7 square roots of m. It's just like if this was x minus 7x. Think, what's the number in front? It's a 1. So the coefficient of the first one is a 1. So it's 1 minus 7, negative 6, and we have negative 6 square roots of m. So it's how many, it's like how many do you have of the square root of m. So letter C here, like radicals, you have to have x, y inside the square root. This square root of y, although the y matches, the radicals have to be identical. So if we combine these, we have 2 square root of xy plus 9 square root of xy. Add the coefficients, keep the like term, and then this plus 2 square root of y didn't combine with anything, so it just comes along to the end. So adding and subtracting like terms, looking for that like radical. So here's 2 for you to try. So pause and give it a try. My like terms, I'm going to box in here. Like term, matching up those radicals. So if I take 3 root 2 minus 8 root 2, that gives me negative 5 root 2. And if I take 6 root 3 minus a root 3, remember there's that 1 there, then it's positive 5 root 3. So if you want to write this as your final answer, negative 5 root 2 plus 5 root 3. It doesn't really matter which one comes first. There's not like a preferred or a correct answer whether the root 2 is first or the root 3 is first. But you want to make sure your signs still match. This is a positive 5 root 3. That's a negative 5 root 2. So when you write your answer out there, can these two be combined? The answer is no, because the roots don't match. In the second problem here, you've got root 2x, and here's another root 2x. You've got a root 2, and you've got a root x. So the only like terms are the negative 15 root 2x and negative 5 root 2x. So that would be negative 20 root 2x. And then the plus 3 root 2 and the plus 4 root x. Again, to combine, your radicals have to have 100% identical radicands. So if the radicands don't match, don't combine those like terms, or don't combine those terms because they're not like terms. So that's my answer. All right, the only problem that might come into play is that sometimes your radicals may appear to be totally simplified, not like terms in any way, but in fact, they may be in disguise. So if we look at this problem, square root of 75, square root of 27, square root of 48. If I simplify, this is 25 and 3, 5 and 5. This is really 5 root 3. 2 root 27. With 27, it's 3 and 9, 3 and 3. I got a pair of 3's that can leave. This is really 6 root 3. And 48 is 3 and 16. 16 is 4 and 4. There's a 4 that leaves. This is really 4 root 3. So what you can see is we actually had, the whole time, we had 3 like terms here, but we don't know that until they get simplified. So you want to make sure your first step is to actually simplify before you determine like terms or not. So, oh, sorry, I'm doing this one to finish. Sorry, I meant to finish this one and then give you the you do. To finish this one off now, I see that all 3 of these are like terms. So I do 5 root 3 minus 6 root 3. That's negative 1 root 3. And then plus 4 root 3 would be 3 square root of 3. So you can't combine until you simplify. So if it's possible to simplify, you want to check that out. So now the you do. So pause and give this one a try. Finding the perimeter of the triangle means you're taking all the values here and adding them together. Right now it looks like there's no like terms, but let's check out if you can simplify. So 20 is 4 and 5. 4 is 2 and 2. So it looks like I've got a pair of 2's that's going to leave this square root. So since there's a 3 already out there, we multiply those two together. And there was a 5 left on the inside that didn't pair up with anything. So it's 6 root 5, 13 root 5, and 10. So it looks like now you have two like terms. So 19 root 5 plus 10, and the units on this one are millimeters because it's a distance, it's a perimeter. So simplify those radicals and then look for like terms. That's the moral of the story when it comes to adding and subtracting. We're going to get into some other operations, so you really want to liken this to compare it to other times where we've added and subtracted. You're always looking for like terms. If there's one thing you've learned in algebra, not everything can be combined using addition and subtraction.